Welcome to Tech with Machines. Today we are going to do hands-on on Spark. In our previous video, we talked about Spark core concepts and we will actually do coding for each of those concepts and understand how really we create a Spark context, Spark session, or how do we create a low-level resilient distributed data set, or how does a data frame get created in Spark. And we'll also go through transformations and actions and what is the key difference between narrow and wide transformations. For today's video, I'm going to use Jupyter Notebook, which I have installed using Anaconda Navigator. That's a prerequisite. If you already are using Spark binary, then you can use that as well in whatever way you feel comfortable. I might create a video on the Spark setup, how you can do it, but I am currently using PySpark and I will be using Jupyter Notebook in most of the video series where we will do hands-on. I will share a link here and I'll put it into the description as well, from where you can actually install Anaconda Navigator, and which will look something like this, and from where you can launch the Jupyter Notebook. So without any further delay, let's start with some basic coding and understand how we can create Spark context and Spark session as the first step. So let's try to deep dive into Spark context, Spark session, and understand all the key differences which we talked about in our earlier video. So as a first step, I am going to create a Spark session, and at the same time I will also create a Spark context. And if you remember, we discussed that there can be only one Spark context per JVM, but there can be multiple Spark sessions within a Spark context. So let's see what happens when I try to create both of them, and how we create them also we'll get to know in this series. So as a first step, I am going to start with Spark session, and generally I will start with Spark session, and if we need Spark context, we'll get the Spark context from that Spark session, because mostly you will deal with higher versions of Apache Spark, so it's better to use the enhanced Spark unified entry, which is Spark session. But in this video, we'll also see how we can actually create a Spark context directly without Spark session, and what are the key differences. So as a first step, as I'm using PySpark, as I mentioned earlier, so I am going to basically import the Spark session from PySpark module, and this is how we do that. We actually do from PySpark.sql import Spark session. If you are not familiar with Python, then I will suggest you to go through the series which I have created on Python, and I will continue adding more videos to it before you jump into Python. Or if you are comfortable with Java, the concepts are pretty much similar. You can code actually in Java as well, because Spark is available in Java language as well. Now I'm going to create a Spark session object, so I will say Spark session dot builder dot app name. I'm gonna call it Spark 101, and I will get or create it if it doesn't exist, and this is how I got the Spark session. Now I will also try to create a Spark context. Now I will not take it from Spark session, but instead I'll create the new Spark context. So for that, we'll say from PySpark import Spark context, and now let's create the object of Spark context. So we are going to say sc is our reference variable Spark context. It's running on a local machine, and the application name is Spark 101. When I run this particular step here, it's going to complain. So as you can see, it says that you can't run multiple Spark context steps. One, because you already have a existing Spark context which you created by get or create, right? So this basically justifies initial key difference which says that there can be only one Spark context per instance. So what I'm gonna do is I'm gonna basically clean up this, and I'll say it restart and clear output. My kernel is restarted. Now I'm actually gonna be commenting out the Spark session to actually show you that the claim is true. So I'll comment these two statements out, and I'm just gonna run Spark context. So let's run this, and as you can see, it successfully created a Spark context without complaining that there are multiple Spark contexts running, right? So this is how you create a Spark context, or you create a Spark session using PySpark module of Python, right? Now let's go back to Spark session alone, and we'll get the Spark context from there. How will we get the Spark context from Spark session? We'll get on that. So let me remove these two lines of Spark context and go back to Spark session. Let's start from creating a Spark context using Spark session. So as earlier, we will load Spark session from PySpark.sql, and we will create the object Spark session dot builder dot app name, which we are calling it as Spark 101 dot get or create. Now we can get a Spark context object from Spark session by saying spark dot spark context. Now in this one, we need a Spark context because we want to create a resilient distributed data set. Whereas if we want to create a data frame, then we can create it directly from Spark. Let's first try to create a data frame before we move to RDD. We can also create a data frame from RDD as well, but just for understanding how data frame is created using a Spark session, let's try to do that. If you remember, we said that data frame is a distributed collection of data which is basically stored as named columns. So it's very important when you are using primitives or scalars, you can't directly create a data frame using that. You'll have to basically map them to a row object so that it can be of the type data frame. So what I'm going to use here is as a tuple to show you how it can create a data frame, and we'll also go through an example where we can create it as a list of integers as well, and map it to a actual type instead of directly giving it as an int, which can fail. Now let's start with a tuple. So let's say I'm creating a list of tuple which is a first name and a last name. Let's say the first name is Rahul and the last name is Roy. Then we have Ravi and last name is Gupta. Then we have Roger, last name is William. So this is how the data structure is created. Let's print it as well to see if it is fine. It looks fine. Now I will create a data frame, and let's name it as df, and I'm going to create it from Spark session. So Spark has something called Spark session has something called Spark data frame, and then you pass it data. I can also give it a schema explicitly saying that my first column is first name and the second column is basically last name. When I run this, I have created a data frame, and I can actually print the data frame schema, or I can actually print the data frame as well, which shows that what really this data frame contains. And I can also do data frame.show, which will show me the values which this data frame has. So this is how the data frames are created. And if you want to really do the stage method in this, you won't be able to do it because toDebug string is something which is used on RDDs. We'll go through what to debug string means now with RDD as well. So I'm just gonna cut this out here. Let's create now an RDD. So we talked about how to create a data frame using Spark session. Now let's create a RDD using Spark context. So I'm just gonna name it as RDD, and I'm gonna create it through Spark context using parallelize method, and I'm gonna give it a range of, let's say, 20 numbers. So this is how RDD is created, and saying it's a Python RDD. So let's also do the same thing which I tried to do with data frame and failed. So this is going to tell me what exactly happened with my RDD. So as you can see, it says that this is a parallel collection RDD, and we have created it using a collection. Okay. Also, I can also check the partitions of a RDD, because RDD generally has the following metadata along with it, one of which stores following metadata along with it, one of which is partitions, basically the set of data splits which are associated with the RDD. So let's say I am gonna say rdd.get num partitions, and it says me that there is only one partition particularly for this RDD. So this is how you create a data frame or a resilient distributed data set using Spark context or Spark session. So that's pretty much about how we can create Spark session, Spark context, RDD or data frame. Now we'll move towards transformations and actions, and we'll continue with this itself, which we created as an RDD. We will talk about transformations and actions, and we'll generally talk about how transformations are actually performed. What does narrow and wide transformation mean? Now, basically, all work data is performed in the sequence of two types: one transformation, another action. And we also understood the transformation is lazy evaluated. Until you actually execute or perform execution, transformations will not be executed immediately. Until you call operation or an action on a transformation, it will not really get executed. Generally, how transformations work is that when they apply transformation to RDD, it creates a new RDD, because RDD being immutable, it can't be modified in place. So it creates a new RDD, and it transforms elements of the given data. They are lazy because when we call an operation or transformation on RDD, it is not going to be executed immediately. And what Spark also does is, if you remember, we talk about the lineage information. Spark actually also keeps a record of each operation, which we call DAG, and it helps it to recover the failed or lost partitions, if at any. That's why it is able to do fault tolerance, and it is resilient. And we'll talk about DAG also in a minute. So we can assume that RDD is a distributed data set on which transformations are applied, and due to laziness of transformations, we can directly start the execution of operations at any time by triggering an action on RDD. So this gives a lot of possibilities for low-level optimizations. Now there are two types of transformations which get applied to RDD, which are called narrow and wide transformations. And if you see here, narrow transformations are basically doesn't require reorganizing data between partitions. They're not shuffling the data between partitions, right? They are basically stacked together and allowing transformations to happen parallelly on different partitions. One partition is resulting into a different partition without really needing to shuffle data from another partition, right? Whereas wide transformation does require shuffling, does require reorganizing data among different partitions, and can result into multiple partitions, can result into multiple output partitions, right? So it does require information from other partitions, like you are doing summing up all values in a column. So Spark will basically collect the necessary information from each partition and consolidate it into a new partition, most likely on another executor, right? But there are exceptions in this case, like collace, which we'll also understand in our few more videos, that may cause the task to work with multiple input partitions, but the transformation will still be considered narrow because input records used to compute any output record can still be found only in a limited subset of partitions. Now let's see how narrow and wide transformations are really occurring with the transformations which are readily available in Spark, like filter, map, or group by and reduce by keys, right? Out of which few are performing narrow transformations and few does perform wide transformations. So let's try to filter our RDD and apply this transformation on our data. So I am going to use the same RDD which we just created with a list of 20 numbers. I will create a filtered RDD and I'll say RDD.filter, and I'm gonna filter it by let's say x greater than 10. Now this is filtered RDD. Let's print its stages as well to see really what happened with it, how many stages are there, and if we do that, it basically pretty much prints the same thing which we printed with the basic RDD, right? So there's no shuffling happening as such with this transformation, correct? And I can now perform an action on that by using collect. So I will collect the data and it is able to give me all the records which are greater than 10. So we really didn't shuffle the data and each partition could be processed independently, though there were only one partition, but as you can see, it really didn't show us that it is doing shuffling. Now the wide dependencies or wide transformations can happen by group by or reduce by key transformations. So with these transformations, the data processing data can be located in several partitions of the parent RDD, which would need to be combined. So for these operations, Spark may perform a shuffle by moving data across the cluster and forming a new stage with a new set of partitions. Let's try to do group by. So now I will create a grouped RDD and we'll do the same thing what we did with filtered RDD. So we'll do RDD dot group by and we will group that by, let's say, x, and x should be divisible by 2. So this created a grouped RDD, and let's now try to print its stages with the same 2 default string. Now as you can see here, it is showing that it did perform shuffle at partition, right? And this shows that this is a wide transformation or a wide dependency. We did collect most of the time, which is nothing but action which is applied to when it is necessary to collect the result or save the result. It saves the data to disk, or it can write the data to database, or output a part of the data to the console. So far we just used collect because it collects the data, and actions in general are not lazy. They'll actually trigger the data processing. Actions are operations that produce values that are not RDD, right? Now let's say I want to get the sum of our filtered data. So I will do filtered RDD dot reduce because I want to get the sum. So let's use a reduce action, and I do lambda a b, and I want to do a plus b, right? So it is generally gonna give me a value here. Sorry, I misspelled this, and it actually what it did is it actually summed up all my elements which were there in the filtered RDD. So it's not really giving me a RDD, but a value as an action, right? So this is all about the transformations and actions, and wide and narrow transformations, and how you can actually see the different stages, what is really happening with the underlying data frame or data set. So Spark generally defines tasks which can be parallelly computed with the partition data on the cluster. Now, with these defined tasks, Spark actually builds a logical flow of operations, and that can be represented as a DAG, which is generally a short form for directed acyclic graph, where the node represents an RDD partition and edge represents a data transformation. Spark builds the execution plan implicitly from the application provided by Spark. So let's say how it happens basically is you have RDD objects where you are actually doing transformations and actions, uh, which will go to DAG scheduler. It will compute a DAG of stages for each job. Stage generally consists of tasks based on the input data partitions, and DAG scheduler will merge some transformations together. For example, if there are multiple map operators being used, it might combine them into one stage. So end result of DAG scheduler is generally a optimal set of stages in the form of task set, which are then passed to task scheduler, and task scheduler launches the task through cluster manager, and it doesn't know anything about the dependencies of stages. And finally, these tasks are given to worker which executes it. So RDD can determine preferred locations for processing partitions. DAG scheduler places computation so that it will be as close to the data as possible, which is what is called data locality. And this is all about Spark core concepts in terms of how you really create Spark context on an RDD, or how Spark really creates a plan to execute those tasks. Thank you so much for watching this video. I hope you liked this video. If you do, please subscribe and feel free to put comments if you have anything which you would like to learn about, or any comments to improve. Thank you so much.